Yeah, my name is Stephen Turner. I'm going to have Carl Flowers come up here in a little bit. He's our master blaster. Yeah, we're in the impact and explosion effect branch at Earth. We're going to be going over alternative method at cutting concrete, so using explosives. So, next slide, please. And so, conical shape charge pavement cutting rails. So our task, cut pavement around craters on 4 sides to establish a square working unit. So, given all required equipment and training, successfully complete a square pavement cut around all area around craters using these conical shape charges for pavement cutting rails. So the pavement surface will be perforated by these shape charges to achieve a cutout perimeter around the crater. So their goal is to produce working cutout without the use of concrete saws with or dry process. Next slide. So we're going to just go over the explosive basics, equipment preparation, typical setup, summary, and questions. Slide. One more. So just a quick basic safety for explosive demolition work. I mean, it's all the typical explosive safety. We want to minimize the number of personnel in the area that will be exposed to the minimal amount of time and the minimal amount of explosives. So pretty much the standard, you know, don't want to have rough handling, no smoking, all that good stuff. Next slide. And this is just a little bit more. So if you've done any, if you're explosively certified, then you kind of, this all should be familiar. So just keep in mind, you know, make sure that you are explosively certified, kind of your demolition operator. Next slide. So list of equipment needed for this. You'll have the shape charges, which you see on the right hand side, just they're conical shape charges. We developed trays to hold these shape charges. They've optimized the standoff and the spacing. And then you'll need dead cord. We have typically been using 8-grain dead cord from the manufacturer of these shape charges. We have done some recent testing, and I believe they did a shot yesterday with military 50-grain dead cord, and we have not seen any problems with initiation. They also need plastic pins. Plastic pins will go down and help hold the dead cord, make sure the dead cord makes good contact with the shape charge for good initiation. Plastic connectors, they're going to hold the trays together. You can either do straight line, 90 degrees, 45, but we got more pictures of that later. Initiators, firing system, what we say is use whatever you're comfortable with. We have a different firing system than military, and so, but, you know, whatever everyone's familiar with is what we use. And then all the rest of the thing is more for crate marking. I believe Will went over that earlier. Yeah, so next slide. This is a typical pavement cutting array after it's all been set up. You notice it's kind of a grainy picture on the right side that cord seated properly in the little cavity in the U-channel. Just want to make sure you get good connection there. Next slide. This is a little bit about the shape charges. They are 15-gram shape charges each. They have 1 gram of booster, 16 grams total. It's either RDX or HMX filled. You can get them both ways. We have not done this penetration, but they've advertised to go through 40 inches of 5,000 psi concrete. We have done up to 24 inches, and we have seen no issues with penetration. We'll caveat that. All of our pavement we have cut was non-reinforced, no rebar in it. So, yeah, and then the 8-gram deck or the military 50. Next slide. And this is a picture of the deck cord. shake charges are classified as a 1.4, while the deck cord is a 1.1. So just for shipping purposes, transportation. And these shake charges were developed for oil well penetration. So with the oil, I believe the oil well industry drill a hole down, put these shake charges in there. They have little guns that shoot all different angles for looking for oil. Next slide. These, like I said, these trays have been optimized for standoff. We've done a lot of testing to find the optimal standoff to let the cone inside the shake charge, once it detonates, that time it's basically the cone to collapse, shoot the jet down into the concrete. And then we've also optimized the spacing between the charges. We wanted to maximize the space that you could between, just to reduce the amount of explosive and still get good connecting cracks. Because once these go off, they just create a bunch of little pinholes, and then it's like connect the dots with cracks between. So, yeah. Next slide. Typical setup procedure. Select the proper location, place the charge array. A lot of that has already been defined with the crater marking. And so the crater repair team usually has already set that. These trays are 14 inches in length, so we just try to get as close as we can, maybe a little bit outside the line, just get as close. Some of the general considerations for the placement that we try to go by, outside the upheaval zone, so by the repair team, outside of any underlying damage that might have already existed or that might have been caused by the detonation of the initial, so new large cracks. We try to utilize pre-existing joints, cut lines, as much as we can, or if we're within about 3 feet of the edge, because it might be about 3 feet of the edge of the slab, we just use the slab as the edge, so we won't have to do any cutting. Next slide. So, as you're placing these arrays out, you want to make sure that there's a shake charge in every hole of every tray. You're going to put the charges, the trays end to end along the cut line, and then use the connectors to help make sure that the trays are in the still line. And the connectors are also used on when you're doing 90-degree corner. Next slide. Yeah, this is. You will use the push pins to help hold the deck more balanced. So we designed we can either do a 90-degree or a 45-degree turn. Either one seems to work for us. We haven't had any major issues doing one or the other. So it just gives more options. Next slide. Good on that. Crossfire was in and out. Come up and ready for the rest.
How we doing, everybody?
Good.
I'm just going to talk to you really briefly about the deck cord placement in these charge trays and such. You can see there, that's kind of a bad example of running deck cord with those sharp bends and such on it. This one is actually where we tried coming into the crater a little bit to try to break up the inside a little bit as well, which we found didn't really work that well. So it's best to just stay with that outside. But obviously with these, what you don't want to happen is have improper deck cord placement, because then you're going to end up kicking one of them out and you're causing yourselves more hazards with, now an explosive shake charge laying out somewhere where you don't even know where it's at. So deck cord placement is really important on getting these done. This is just basic info on deck cord. No need to stay on that. You can go to the next slide. You can see some close-up pictures there of making sure that that deck cord is seated all the way down into that shake charge. And then, of course, you want to make sure that you don't have too much of a bend on deck cord. Anybody that's ever worked with deck cord kind of understands that kind of stuff. You don't want to have a blowout on your deck cord by doing more than a 90-degree bend. The other important part here, which isn't really shown in this picture, is if you're familiar with setting up deck cord, you want to have a ring main type scenario where the deck cord comes all the way back and ties back into itself, right? So it's like a balloon kind of thing where it comes all the way back around. We found that if you don't, there's enough time by the time that deck cord gets to the end of that run that it will kick out a couple of those shape charges on the end. So again, something you don't want. And depending on what size you're using, the best thing with deck cord is to keep it in one run and cut it as many amount of times as possible. So we always found to just keep it on the spool until you're done. You get back to that point at the end and then tie it back in. Next slide. I think this is actually a video, if it'll work. Otherwise, there's not a whole lot to talk about. This is just kind of showing the whole setup from start to finish. This has been a process going on 4+ years at this point, on and off, not solid, to come up with the right standoff, the right spacing in between shape charges, going through a couple of different shape charge iterations, getting the pins. There's a couple different versions of the actual trays. The ones that we're going to be using out here are the lightweight trays. They still do take up a little bit of space, so that's probably the next would be the next step in these is trying to reduce the space they take up. You can go to the next slide. So final checks, after you've got everything set up, like we just saw it there, before you do the shot, you just go back, make sure everything's seated down into each shape charge properly, and make sure all your deck cord is run the right way. And then, of course, clear the area and do your initiation. Pretty straightforward. Next slide. This should be a video as well of us actually going a shot. You look real close, you can see the trays laying out there. We had to wait for the trucks to go by. So most of that debris you see flying, that's the tray itself, which is good because you want the tray to be thrown and not the frag from the actual shape charge. But the frag for these, like I said, each one of them is 16 grams. The frag is existent, but it's very minimal. What did we come up with the distances? It's less than 300 meters, which is what you're going to keep clear anyway. So, 300, 400 feet out of the frag being thrown. I mean, that's minimal for demolition work. So, go ahead, next slide. Of course, misfires, that's whatever your procedures are for misfires for your organization. The Navy has different ones than the Air Force, than has the Army, and our other partners are, I'm sure, going to have different ones as well. So, just make sure you have that as aware of. This is just the misfire procedures that we wrote up for just general practice. I'm not going to go into great detail on these. There's a couple different services mentioned there about wait time after misfire and all that kind of stuff. But it always is something to keep in your back of your mind. Next slide. All right, so that's just our summary of everything we went over. Next slide. Questions about shape charges, the charge array? Go ahead.
Apologize if I missed it, but when we employ the shape charges, how likely are we to see additional cracks along the outside of the perimeter, and how far out and how deep are we talking?
we do have corner cracks, so 90-degree corner, you will have them, and they usually, from what we've seen, if it's within a slab, you know, within a 20 by 20 foot concrete section, they'll run to the corners until there's a free edge or a cold joint or something. And we haven't really, you know, expanded too much into, you know, the depth of them, but they are more minor cracking.
Yeah, most of them we see, you wouldn't be able to get a quarter down in the crack.
Yeah,
Okay.
that's
They're
when
pretty minor
if
cracks.
you're within like about 3 feet from the edge, you're gonna see a lot more, and that's why we say just go ahead and go corner.
Sure.
When you're doing that, is just so you're not gonna have that crack.
Yeah, you could do a three-sided,
Yeah.
you know, shot with these to where if you're right on the edge, say the crater's right along the edge, you know, just do three sides like you would cut with the saw. There's no use to do one real close to the edge, just go yeah, all the way. But cracking is definitely an issue
Okay.
outside of the cut area.
Like to the point where it's disturbing, like the integrity.
It all depends on the situation that you're in. I mean, we haven't seen anything that drastic in what we've done, and most of the pads we've done are pretty small compared to an airfield. But I mean, it is something that you would have to take into consideration.
Okay. And the cracking from the shape charge, between the shape charges, it's not as, you know, of course, it's not going to be as wide as the diamond blade saw. You know? So you know, on the breakup and removal part, it is still kind of locked in. But with equipment, definitely, you know, we see there's good separation between the shape charges.
Yeah, much like with the diamond saw, you have to have space inside the cutout area to push things too, because it's a very thin crack.
Okay. Thanks, Julie.
Okay.
How much of a depth of a cut does that make on average?
We've done up to 24 inches. And we've done all the way up to 24 inches of concrete, and it hasn't stopped. It's not like that's the end of it. There's holes in the ground afterwards. So, I mean,
In regards to the time on target, from start to finish of assembly, what do you see? Is it expeditious as opposed to cutting?
It depends on the size of the crater, of course. It has been competitive with the cutting times. So about, what, a 10 by 10, we're 15, 20 minutes set up.
it depends on
Yeah,
how
clear.
good your operators are too. I
Yeah.
mean, if it's somebody, and how many people you have. Like, obviously, the more people you can throw at this, fill in, you know, we don't have a complete package yet, let's put it that way. So, the trays and the shape charges are separate right now. This is not a fully developed project where it has all been put together and it's sitting in the ASP ready for you already. So right now, it takes a little bit more time for setup because you gotta put the shape charges in each individual hole, and then you gotta lay out the trays and all that kind of stuff. So, but if it comes to full use and is out there for everybody, the theory is that it'll already be pre-packed. And maybe at some point it might even get to a scenario where it's already pre-sized, where you just have like this expandable